Hello students, so we have seen the properties of determinants. Okay, now we'll prove or solve some questions based on the properties of determinants. So this is one question where we have to prove the determinant is equal to a cube. So we can reduce, before solving this determinant, we can reduce this determinant using properties. Okay, now we want here a cube, so we have to eliminate some of the elements. Okay, so we have to apply some row operations or column operations. So I'll start by applying row operations, and I'll make these two rows 0, that is these two elements 0. So to make them 0, I'll have to take R2, I'm changing to R2 minus 2R1, right? And R3 minus 3R1. So I'll get A 0 0, A plus B, A plus B plus C. This will be 3A plus 2B minus 2A minus 2B, right? So I'll get 3A minus 2A, that is A. Then here it will be 4A plus 3B plus 2C minus 3A minus 3B minus 3C. So 3B, 4A minus 3A, A, and 2C minus 3C, it will be minus this is 3R1, right? So okay, here it is into 2 you have to take, yeah, right, sorry. 4A plus 3B plus 2C minus 2A minus 2B minus 2C. Okay, 2C cancels. 4A minus 2A is 2A, and 3B minus this is B. Okay, now you have to take 3. So 6A plus 3B minus 3A minus 3. So it is 3A, and 10A plus 6B plus 3C minus 3A minus 3B minus 3C. Okay, so 10A minus 3A is 7A, 6 minus 3, 3. Okay, yeah. Now we want a cube, so again we can reduce these two elements, right? So reducing, you have to take R3, I am reducing to R3 minus 3R2. So I am making this element 0. And this will be 7A plus 3B minus 3R2. R2 is 2 into 2, 4. Six A minus 3B, so it will be A. Okay, now if you expand along this column, you will get a cube. Okay, so solving determinant, you will get A into A square minus 0, so this will be a cube. So to solve any kind of this type of problems, you have to first reduce. Okay, so try reducing the determinant using properties of determinant. Okay. Next question, you are given a determinant, you have to prove this. Okay, so here the elements are not like this, right? So you have to convert them in this form first. Okay, so if you take this minus, okay, then you will get these elements in this form. So I'll take R2, I'm reducing to R2 minus R1. Okay, so I'll get B minus A, and for R3 I'll take R3 minus R1. Okay, so you'll get determinant 1A B C. So this will be 1 minus 1 0, this is also 0, B minus A, C minus A. Okay, so next here it will be CA minus BC, so I'm taking out C, so it will be A minus B. Okay, again here it will be AB minus BC, so B you can take out, so you'll get A minus C. Okay, so in next step you can take out A minus B outside from R2 and A minus C outside from R3. So you will get 1 0 0 A B C. This will be minus 1. This is also minus 1. C and B. Okay. Now we want to take out C minus A. So to take out C minus A, can we expand along this? Just try. So if you expand along column 1 C1, okay, you will get 1 into minus B plus C. Okay. We have A minus C, right? What we wanted, C minus A, right? A minus B we got. This is minus B minus A minus B, B minus C, and C minus A. So this will get so if you take minus outside from this, so this will be C minus A, and minus outside from B minus C, so this is B minus C. Minus minus is plus, you will get A minus B, C minus A, and B minus C. Okay. Let's solve this. So it is already given that determinant is 0. You have to show that 1 plus xyz is equal to 0. So this you have to take outside. Okay, so let's start. So here 1 plus is given, so you can use the property of a determinant where you can add the elements of the determinant, right? So if I expand this, I can write this in terms of two determinants, that is addition plus cube y cube z cube. Okay, now I'm going to write this as 1 here and xyz here. Okay, so I'm interchanging the elements, that is columns. I'm interchanging the columns. Okay, so I'll write this as 1 1 1. So third column becomes first column, then I'll write xyz, and then I'll write x square y square z square. Okay, So if you interchange any row or column, you have to take out minus sign outside. Now I am interchanging 2 times, that is I am interchanging this with this and then this with this, right? So this will be square. Okay, plus I am taking out x from first row, y from second row and z from third row. So I'll get 1 x square, 1 y square, 1 z square. Okay, now I'll take this together, so this will be 1 plus xyz. Okay, so now I can write this common I have taken, so xyz, x square, y square, z square. Okay, now I have to show that this term is 1, because I want this x1 plus xyz equal to 0, right? So I'll take I'll just subtract this R2 from R1 from R2, and that is I am making this as 0, both these entries as 0, that is I am applying R2 minus R1 and R3 minus R1. Okay, so here it will be y minus x, z minus x square, y square minus x square, z square minus x square. Okay, now this y square minus x square, you can write it as y minus x, y plus x, correct? So you can take out y minus x common from R2 and z minus x common from R3. So it will be 1 1 and this will be plus. Okay, now if you expand this, let's see what you get. Expand along C1, so it will be 1 z plus x minus y minus x, so this will be z minus y. Okay, and since the determinant is given equal to 0, we have proved determinant to be equal to this, and this is given equal to 0. Okay, now they have in the question they have given that x, y, z are different, means x is not equal to y, z is not equal to y. So this, that is y minus x is not equal to 0, z minus x is not equal to 0, and z minus y is also not equal to 0. So the only term which remains is this, so this has to be equal to 0. So from this we can write 1 plus xyz is equal to 0. Okay.